National Electrical Code, or NEC, does not explicitly state any specific spacing requirements for J-hooks used for low-voltage cables. However, Article 820.31 of the NEC does address the installation requirements for low-voltage cables, providing general guidance that may be applicable to the spacing of J-hooks. Industry best practices for J-hook spacing for low-voltage cables recommend these guidelines. For horizontal runs, space J-hooks approximately 12 to 18 inches apart. For vertical runs, space J-hooks approximately 24 to 36 inches apart, depending on the cable weight and support system. I-bends and crossings provide additional support for cables by spacing J-hooks closer together. The specific spacing requirements for J-hooks may vary depending on various factors, including cable weight, where heavier cables require more frequent support. Some cables, such as shielded or armored cables, may require additional support. Extreme temperatures or vibration can affect the support requirements. The strength and rigidity of the support structure can influence the spacing. Ensure that J-hooks are securely fastened to a solid support surface. Avoid over-tightening the J-hooks, as this can damage the cables. Use appropriate cable ties or clamps to secure the cables to the J-hooks. Allow for sufficient slack in the cables to accommodate expansion and contraction due to temperature changes. It is important to elaborate on each of the factors. Cable weight is a critical factor because heavier cables exert more downward force on the J-hooks and the supporting structure. If the spacing is too wide, the cables may sag excessively, potentially leading to stress on the cable insulation and conductors. This sagging can also make the installation look unprofessional and may create hazards. To address this, heavier cables should be supported more frequently, reducing the span between J-hooks. This ensures that the weight is distributed evenly, preventing excessive strain on any single point. For instance, if you are running a large bundle of communication cables, such as Cat6 or fiber optic cables, the combined weight can be significant. In such cases, reducing the spacing to the lower end of the recommended range, such as 12 inches for horizontal runs and 24 inches for vertical runs, is advisable. Also, always consider the manufacturer's specifications for the maximum allowable sag for the specific type of cable being used. Different cable types have varying levels of flexibility and tensile strength. For example, shielded or armored cables are typically more rigid and heavier than unshielded cables. This means they require more robust support to prevent damage or deformation. Shielded cables are often used in environments where electromagnetic interference is a concern, such as near electrical equipment or machinery. The shielding adds to the weight and stiffness of the cable. Armored cables, which have a metallic outer layer, are even heavier and more resistant to physical damage. These types of cables may require J-hooks with a higher load-bearing capacity and closer spacing to maintain their integrity. In some cases, specialized J-hooks with cushioning or wider support surfaces may be necessary to prevent the cable from being pinched or compressed. Extreme temperatures can significantly affect the properties of cable insulation and support materials. High temperatures can cause cable insulation to soften and sag, increasing the need for closer J-hook spacing. Low temperatures can make the insulation brittle, making it more susceptible to cracking or damage if the cables are not properly supported. In environments with significant temperature variations, it is essential to use J-hooks made from materials that can withstand these changes without degrading. For example, using J-hooks made from UV-resistant polymers in outdoor applications can prevent them from becoming brittle and cracking over time. Similarly, using metal J-hooks with the corrosion-resistant coating can protect them from rust and degradation in humid or corrosive environments. Vibration is another critical factor, especially in industrial or mechanical settings where machinery operates. Continuous vibration can cause cables to shift and rub against the J-hooks or supporting structure, leading to abrasion and eventual failure of the cable insulation. To mitigate this, J-hooks should be securely mounted and may need to be supplemented with vibration-damping materials. For example, using rubber grommets or cushioning pads between the J-hooks and the cables can help absorb vibrations and prevent chafing. Additionally, ensuring that the J-hooks are properly tightened and that the cables are securely fastened to the J-hooks can minimize movement and reduce the risk of damage. The strength and rigidity of the support structure to which the J-hooks are attached also play a crucial role in determining the appropriate spacing. If the support structure is weak or flexible, it may not be able to adequately support the weight of the cables, even with closely spaced J-hooks. In such cases, it may be necessary to reinforce the support structure or use a different type of support system altogether. For example, if the J-hooks are being attached to a drywall surface, it is essential to use appropriate anchors or mounting hardware that can provide sufficient support. Alternatively, running cables along a more rigid structure, such as a metal strut or beam, can provide a more stable and reliable support system. It is also important to consider the overall layout and design of the cable run. In areas with frequent bends or turns, the cables will experience increased stress and strain. Closer J-hook spacing is necessary in these areas to prevent the cables from being pulled or stretched excessively. Similarly, at points where cables cross over or under other objects, additional support should be provided to prevent the cables from sagging or being damaged. In addition to these factors, it is important to consider the specific requirements of the application. For example, in healthcare facilities or data centers, maintaining proper cable management is critical to ensure the reliability and performance of the systems. In these environments, more stringent spacing requirements may be necessary to minimize the risk of cable damage or interference. Ensure that J-hooks are securely fastened to a solid support surface. This is a fundamental requirement for ensuring the long-term reliability and stability of the cable installation. If the J-hooks are not properly secured, they may loosen over time, causing the cables to sag or become damaged. The type of fastener used will depend on the material of the support surface. For wood surfaces, screws or nails may be appropriate. For concrete or metal surfaces, anchors or bolts may be necessary. It is important to use fasteners that are specifically designed for the application and that are capable of supporting the weight of the cables. Avoid over-tightening the J-hooks, as this can damage the cables. Over-tightening the J-hooks can compress the cable insulation, leading to cracking or deformation. This can compromise the electrical performance of the cable and may even create a safety hazard. When tightening the J-hooks, it is important to use a torque wrench to ensure that the fasteners are tightened to the proper specification. If a torque wrench is not available, tighten the fasteners until they are snug but not excessively tight. Use appropriate cable ties or clamps to secure the cables to the J-hooks. Cable ties or clamps help to keep the cables neatly organized and prevent them from shifting or sagging. They also provide additional support to the cables, reducing the strain on the J-hooks. There are many different types of cable ties and clamps available, so it is important to choose the right type for the application. For example, nylon cable ties are a good choice for general-purpose applications. Velcro cable ties are reusable and are ideal for applications where the cables may need to be moved or reconfigured. Metal clamps are more durable and are suitable for use in harsh environments. Allow for sufficient slack in the cables to accommodate expansion and contraction due to temperature changes. Cables expand and contract with changes in temperature. If the cables are installed too tightly, they may be stressed or damaged when the temperature changes. To prevent this, it is important to allow for sufficient slack in the cables. This can be achieved by leaving a small loop or coil of cable at each J-hook. The amount of slack required will depend on the length of the cable run and the expected temperature range. By following these guidelines, you can ensure that your low-voltage cables are properly supported and protected, minimizing the risk of damage and ensuring the long-term reliability of the installation. It's essential to remember that while the NEC provides general guidance, the specific requirements for your installation may vary depending on local codes and regulations. Always consult with a qualified electrician or electrical engineer to ensure that your installation meets all applicable requirements. Let's now explore some practical examples to illustrate these concepts. Imagine you are installing a network of Cat6 cables in an office building. The cables will be run horizontally along a suspended ceiling grid. In this scenario, you would want to adhere to the recommended spacing of 12 to 18 inches between J-hooks. Given the weight of the Cat6 cables, you might opt for the closer spacing of 12 inches to ensure adequate support and prevent sagging. Additionally, you would use cable ties to bundle the cables together and secure them to the J-hooks, preventing them from shifting or becoming disorganized. At each bend or turn in the cable run, you would place additional J-hooks to provide extra support and maintain the cable's bend radius. Another example is when installing fiber optic cables in a data center. Fiber optic cables are more sensitive to bending and stress than copper cables, so it's crucial to maintain their integrity during installation. In this case, you would use J-hooks specifically designed for fiber optic cables, which have a wider and smoother support surface to prevent pinching or crimping. The spacing between J-hooks would be even closer, perhaps 12 inches or less, to ensure that the cables are well supported and that their bend radius is not compromised. Furthermore, you would pay close attention to the cable's slack and routing to avoid any sharp bends or twists. Consider an outdoor installation of low voltage lighting cables. The cables will be exposed to varying temperatures and weather conditions. In this situation, you would use J-hooks made from UV-resistant and weather-resistant materials to prevent degradation over time. The spacing between J-hooks might be adjusted based on the expected temperature fluctuations and wind loads. You would also ensure that the J-hooks are securely fastened to a robust support structure to withstand the elements. Additionally, you would use cable ties that are specifically designed for outdoor use, which are resistant to UV radiation and moisture. Let's consider an industrial environment with heavy machinery. Cables are subject to vibration and potential physical damage. In this setting, you would use heavy-duty J-hooks made from metal or reinforced plastic. The spacing between J-hooks would be closer to minimize cable movement and prevent abrasion. You would also use vibration-damping materials such as rubber grommets to isolate the cables from the machinery's vibrations. Additionally, you might consider using armored cables to provide extra protection against physical damage. To summarize, the key considerations for J-hook spacing for low-voltage cables are firstly, understanding the NEC guidelines and industry best practices. Secondly, assessing the cable weight type and environmental conditions. Thirdly, evaluating the support system's strength and rigidity. Fourthly, ensuring proper fastening and cable management. Fifthly, allowing for sufficient slack for temperature changes. By carefully considering these factors and following the recommended guidelines, you can ensure a safe, reliable, and professional cable installation.